To deliver a software product, we use different types of models for testing. One of them is Cocomo model. In this Cocomo model, we plan the software resources, analyze them, and then give the design and then perform validation and verification tests before delivering the software product. Let's go into the Cocomo model and see the steps involved to deliver a software product. Cocomo model generally stands for cost constructive model. It is one of the most widely used software estimation model in the world. It was developed by Barry Boehm in 1981 to estimate the number of man months it would take to develop a software project by planning the resources and analyzing its design and sending it for verification. It also predicts the effort and schedule based on the software size to deliver the product. There are three types of models in Cocomo model. They are basic model, intermediate model, detailed model. As given the names, they also follow the same. Organic mode, they follow small and simple projects. Semi-detached mode, intermediate projects. Detailed mode, big and difficult projects. In Cocomo basic model, it is used to find the software development effort using the lines of code. You can find the lines of code using the below formula, and then the explanation of the formula is given. E is effort applied in person month, D is the development time, K log is kilo lines of code, that is the lines of code you type for the software development, and then P is the person required to accomplish the task within the estimated time. As discussed earlier in the previous slide, Cocomo model consists of three modes: organic mode, semi-detached mode, and embedded mode. The coefficients of A, B, C, D are given in the following table. Here we can find that C is common for all the modes and D is the lowest among the table. We can also find that in embedded mode the coefficient of A is very high. Intermediate model, we can find that extension of the basic Cocomo model. The estimation model makes us to find that the cost driver attributes to compute the cost of software. These attributes get a 6-point scale ranging from very low to extreme high condition. The below formula is given for the same intermediate model. Table helps us to find the cost drivers and the attributes involved. In cost drivers, we have the following attributes such as product attributes, which comprises of required software reliability, size of application database, complexity of software, and then we move on to the hardware attributes. Hardware attributes comprises of runtime performance constraints, memory constraints, viability of virtual machine, computer turnaround time. And then we move on to the personal attributes such as analyst capability, and then software engineer capability, and then application experience, virtual machine experience, programming language experience. Project attribute is the comprises of use of software tools, application of software engineering methods, required development schedule. We can also find the ratings of the given cost driver attributes as very low, low, nominal, high, very high, and extra high. As discussed earlier, it is a 6-point scale ranging from very low to extreme high. Values for AI and BI coefficient for various class software projects are mentioned here. Here we can infer that the organic mode has higher coefficient value than the embedded. The values of coefficient CD and DB are taken from the before table. Coming to the last model of the Cocomo model is the detailed Cocomo model, which uses the same equation for estimation as the intermediate model. This model can estimate the effort, duration, and the person of each development phase, subsystem, modules. Here 4 phases are involved, such as requirement planning and product design, detailed design, code and unit testing, integrate and test. Multipliers or detailed Cocomo are given as the following phases: requirement planning and product design, detailed design, code and unit test, integrate and test, and the values are given in a 5-point scale from very low to very high. Using these detailed cost drivers, an estimate is determined for each phase of the life cycle.